Have you ever walked into a room where the lights magically turn on as soon as it got dark? Or maybe you've seen a robot that can follow a black line on the floor with a perfect precision? Behind all of these smart tricks is a tiny but powerful component, the light sensor. And today, in Lesson 10 of our Arduino for Beginners series, you'll learn exactly how this component works. And by the end, we will even build our own light control LED system. Sounds good? Let's dive in. So what exactly is a light sensor? The light sensor we are using today is technically called a photoresistor or LDR, light dependent resistor. It's a special type of resistor whose resistance changes depending on how much light hits it. Here's the simple rule: more light, lower resistance; less light, higher resistance. You can think of it like a potentiometer you don't have to turn with your hand. Instead of twisting a knob, light itself changes the resistance for you. Now, if you've been following this series from Lesson 1, you already know what the resistance is and how potentiometers work. Back in Lesson 9, you built a project with an actual potentiometer, where you manually adjusted resistance to control voltage. A photoresistor is just another flavor of the same idea. It's like an automatic potentiometer. But photoresistors aren't the only way to detect light. There are photodiodes, which are faster and used in things like TV remotes, phototransistors, which are basically light-sensitive switches, and even digital light sensors, which give you more precise values and lux. For beginners though, photoresistors are the easiest to start with because they are cheap, simple, and perfect for projects where you just need to know, is it bright or dark? Now you may be thinking, where do we use them? Well, pretty much everywhere. Automatic night lights, camera light meters, street lamps that turn on by themselves, and one of the coolest examples, line following robots. These little robots shine light onto the floor and measure the reflection to decide if they are on the track or drifting off course. I won't go too deep into semiconductor physics here, that's not the goal of this lesson, but if you're curious about the science, I'll leave a great article in the description where you can dive deeper. Before I move on to the hands-on project, I want to thank the sponsor of this series, GF Robot. GF Robot is one of the world's top suppliers of electronics for makers and roboticists. From simple sensors to advanced single-board computers, they cover it all, affordable, reliable, and shipped worldwide. For this series, they provide me with the Mind Plus Arduino coding kit, which has everything we need for all 24 lessons. That includes the Arduino board, shields, LEDs, sensors, etc. Basically, a complete toolbox for learning electronics the fun way. So, if you want to follow along with me and build these projects at home, I highly recommend checking out the Robot store. I'll leave a link in the description. And of course, huge thanks to the Robot for sponsoring this series and making STEAM education accessible to everyone. Alright, let's put theory into practice. Today's project is a light-controlled LED system. The idea is simple. When it's dark, the LED will automatically turn on. When there is light, the LED will turn off. It is basically the same principle used in those outdoor garden lamps that glow at night and recharge in the daytime. For this project, grab your Mind Plus Arduino coding kit and pick out Arduino board, input-output expansion shield, red LED module, analog ambient light sensor, the photoresistor, some jumper wires. Assembly is straightforward. Plug the expansion shield onto the Arduino, connect the LED to pin 2, connect the photoresistor to analog pin A5. That's it for hardware. You can refer to this diagram to help you with assembly. Now let's get into the code. Head over to the GitHub repository for this series. Link is in the description. And copy the code for today's lesson. Once you paste it into the Arduino IDE and hit upload, your project will be ready to go. But instead of just running it, let's break it down so we really understand what is happening. We start by defining our variables and telling the Arduino which pins we are using. Nothing new here, you've done this in previous lessons. In the loop function, we use analog read to get the sensor's value. This gives us a number between 0 and 1023. Closer to 0 means dark. Closer to 1023 means bright light. Remember, this is the exact same concept we saw in the potentiometer lesson, but now the knob is replaced by light levels. We then compare this value to a threshold, say 500. If the reading is below 500, it's dark, so the LED turns on. If it's above 500, there is enough light, so the LED turns off. Here's the fun part. You can experiment with that threshold. If your room is very bright, 500 might be too low, so you can try 700 instead. This is a great exercise in calibration, which is something you do all the time in real-world electronics. And that's it. You now have a working automatic light controller. This might look simple, but trust me, it's a powerful building block. You need this exact principle when we get to lesson 13, where we will start our very first big project. Before we wrap up, I have some exciting news. I'm currently working on a masterclass where I'll teach you how to build a completely drone with Arduino. And this won't be a simple project. We are talking about 3D printing, custom PCBs, advanced coding, and other resources you need to make it yourself. If that sounds interesting, I've set up a waiting list. The link is in the description if you'd like to be the first to know when it launches. And that is the end of lesson 10. Today you learn what a photoresistor is, how it works, and how to use it to control an LED based on light levels. In the next lesson, we are moving on to another fascinating input device, the sound sensor. You'll learn how to detect sound with Arduino and how to use it in your project. Until then, check out the video on your screen right now. It will help you keep building your skills step by step. Thanks so much for watching, and I'll see you in the next one.